can do video on design of a mat footing. In this video, you will learn how to assign the properties and run analysis and design. Now click once on the footing area. Verify the selection in the bottom left corner. Then go to the Assign menu and assign the correct soil property, Soil 1. Now right-click on the area above the footing and change the rebar material to HYSD 415. Zoom in a bit, and right-click on the column area to check the rebar material. If you right-click on the center of the columns, the rebar information will not be shown. So zoom in the model as per your convenience. In this way, you can check the rebar information in all the models. Then right-click on all the design strips, one by one, and change the rebar material to HYSD 415. The rebar material has been assigned to the footing, columns, and the design strips. Now you will be assigning the loads. The loads in the corner columns are different from that of the other columns. So, you have to select the points of load application separately. First select the force and columns. Verify the selection in the bottom left corner. Then assign the dead load of 2000 kilonewtons and change the size of load to 400 by 400 millimeters. Click on OK, and the dead load has been assigned in the corner columns. Again, you will be applying the live load in the same points. You can select the 4 points again, but here we are showing you a shortcut. Go to the Select menu and click on Get Previous Selection. All the 4 points that you have selected in the previous step will be selected again. Now assign the live load of 800 kilonewtons in the 4 points. Next, select the centers of the 2 columns of 450 by 350 dimension. Then assign the dead load of 1400 kilonewtons. Make sure to change the size of the load. Once the dead load is assigned, select the points again, and assign a live load of 600 kilonewtons. Similarly, select the centers of the other 2 columns, and assign the dead and live loads of value 1400 and 600 kilonewtons respectively. You must be wondering why the 4 columns were not selected together. This is because, although the loads of 1400 kilonewtons and 600 kilonewtons are same in both C2 and C3 columns, the size of loads are different. Hence you are assigning 2 columns at a time. All the loads on the footing has been assigned. You can right-click on any of the points to see the loads information. You can now proceed with the analysis of the model. Go to Run, and click on Run Analysis. Save the file, and wait as the software runs analysis on the mat footing model. The displacement of the slab regions are displayed by default. You can check for the other values, as shown in the previous videos. Go to Run, and click on Run Analysis. Then select the Show Punching Shear Design in the Display menu. The ratios are all more than 1, so you have to go back and change the properties. Unlock the model first. Go to the slab properties, in the Define menu. Increase the thickness of the footing to 600 mm. Now run analysis and design again, and check for the punching shear ratios. The values are still greater than 1, in some of the points. For the footing to pass the design check, the punching shear ratios at all the points must be less than 1. Again unlock the model, and this time change the footing thickness to 800 mm. Now run analysis and design again, and check for the punching shear ratios. This time all the values are less than 1, which means the footing with the assigned properties has passed the design check. You can view the other analysis, design, and detailing results, as illustrated in the previous modules. In the next module, you will be doing the final project of the Foundation Design course. Thanks for watching.